Welcome to Session 3 of our TI-84 Calculator Primer. Today, we will explore matrices, sequences, combinatorics, and special graphing modes. By the end of this session, you will have the tools you need to tackle a variety of problems in your Honors Precalculus course. In today's session, we will cover several important topics. First, we will learn about matrices, including how to use the matrix editor, perform arithmetic, find inverses and determinants, and use reduced row echelon form to solve systems. Next, we will explore sequences and how to compute them, including combinations and permutations. Finally, we will dive into parametric and polar modes, where we will learn about tangent lines and shading. Let's start with the matrix menu. To access it, press the second key and then the matrix key, which is labeled as X inverse on older models. You will find three tabs: Names, where you can select stored matrices; Math, which contains operations like determinant, reduced row echelon form, and inverse; and Edit, where you can create or modify a matrix by setting its dimensions and entering its entries. Now let's go through the steps for entering a matrix. First, press the second key and then the matrix key. Navigate to the Edit tab and select a matrix, like A. Set the dimensions by typing the number of rows and pressing Enter. Then type the number of columns and press Enter again. Enter each entry one by one, pressing Enter after each value. When you're finished, press the second key and then quit to return to the home screen. For example, to enter the matrix A with dimensions 2 by 2, type 2, 1, 3, and -4. Let's discuss matrix operations. After entering your matrix, press the second key and then the matrix key to access the Names tab. You can perform operations like multiplication by entering A times B on the home screen. Remember, you can also edit the matrix and return to the home screen to perform these operations. It's important to ensure that the matrices you are multiplying have compatible dimensions. When performing matrix arithmetic, select your matrices from the Names tab after pressing the second key and then the matrix key. You can use standard operators like addition and multiplication. Keep in mind that for matrix addition, the matrices must have the same dimensions, and for multiplication, the inner dimensions must match. If you encounter an error message about dimension mismatch, double-check your matrices. Next, let's talk about the inverse and determinant of a matrix. To find the inverse, select your matrix from the Names tab and press the X inverse key, then Enter. Only square matrices with a non-zero determinant have inverses. To find the determinant, go to the Math tab, select the determinant function, and choose your matrix. If the determinant is 0, the matrix is singular and does not have an inverse. Now, let's explore reduced row echelon form, or rref, which is a powerful tool for solving systems of equations. First, write the augmented matrix for your system. Enter it in the matrix editor. Then, on the home screen, access the Math tab and select rref, followed by your matrix. The solution will be found in the rightmost column of the reduced matrix. This method works for systems of various sizes. Let's see rref in action. First, enter your augmented matrix into A. After quitting back to the home screen, access the Math tab and scroll down to rref. Select your matrix and press Enter. The augmented matrix will transform into row echelon form, and the identity matrix on the left indicates the solutions can be read from the right. For our example, we will solve a three-variable system. The equations are x minus y plus 2z equals 6, 2x plus y minus z equals 1, and 3x plus 2y plus z equals 2. First, we create the augmented matrix and enter it as a 3 by 4 matrix in A. Then we compute rref of A. The resulting matrix shows that x equals 1, y equals -1, and z equals 2. Now it's your turn to practice with matrices. Solve the system given by 2x plus y equals 7 and x minus 3y equals -2 using rref. Then verify your solution by computing the product of the inverse of matrix A and matrix B, where A is a 2 by 2 matrix and B is a 2 by 1 matrix. You should find that both methods yield the same results. Next, we will transition to sequences and combinatorics, focusing on how to compute sums and perform counting on the TI-84. This will be very useful in the upcoming chapters. Let's look at the seq function for generating sequences. To access it, press the second key, then List, and navigate to OPS to find Seek. The syntax for this function includes the expression for each term, the variable, the start and end values, and the step size. For example, using seek with k squared from 1 to 5 will generate the sequence of perfect squares, 1, 4, 9, 16, and 25. Now let's compute series using the sum function with CQ. To find the sum of a sequence from k equals a to b, you can wrap seek inside sum. Access the sum function from the list menu and use it to compute sums like sum of k from 1 to 10 or the sum of k squared from 1 to 10. These are useful for series problems you will encounter. To graph sequences and series on the TI-84, first change the mode to sequence graphing. Enter your formula for UN in the Y equals menu. Set the appropriate window settings for n values. Press Graph to see the sequence plotted as discrete points. For partial sums, return to function mode and use the sum function to compute the total. Next, let's explore the Math PRB menu for combinations and permutations. To find permutations, use NPR, and for combinations, use NCR. The syntax requires you to type the first number, select the operation, and then type the second number. For example, to find 10, choose 3, you would enter 10 NCR3, which equals 120. Let's find the fifth row of Pascal's triangle using binomial coefficients. Compute each coefficient from k equals 0 to 5 by using NCR. You can also use the seek function to generate these values. The results will be 1, 5, 10, 10, 5, and 1. Additionally, you can verify that the sum of these coefficients equals 32, which is 2 raised to the power of 5. Now, let's explore special graphing modes, including parametric and polar graphing, as well as drawing tools available on the TI-84. In parametric mode, you can graph curves that depend on a parameter t. Change the graph type to parametric in the mode settings. Enter your equations for x1t and y1t as functions of t. Set the window settings for t and the x and y ranges. This mode allows you to graph shapes like circles and ellipses. In polar mode, you can graph equations of the form r equals a function of theta. Change the graph type to polar and enter your equation for r as a function of theta. Set the appropriate window settings for theta and the x and y ranges. Common polar curves include circles and roses, which can be graphed effectively in this mode. Let's walk through the steps for graphing in both parametric and polar modes. For parametric, enter your equations for x1t and y1t, set the window for t values, and graph to see the curve traced out. For polar graphs, enter your polar equation, set the window for theta values, and graph to see the polar curve. Remember to use z-square for accurate proportions. For our example, let's graph the unit circle using parametric equations. Switch to parametric mode and set x1t to cosine of t and y1t to sine of t. Set the window for t from 0 to 2 pi and press Graph. You should see a perfect unit circle centered at the origin. If you forget to use z-square, it may appear as an oval instead of a circle. To draw tangent lines on your graph, press the second key, then Draw and select the Tangent option. This allows you to draw a tangent line to a function at a specified x value. After graphing your function, enter the x value for the tangent line and the equation will be displayed. You can use the Clear Draw function to erase any drawings when you're done. The Shade feature allows you to visualize regions defined by inequalities. To shade between two functions, press the second key, then Draw and select the Shade option. Input the lower and upper boundary functions along with optional horizontal limits. For example, to shade the area between y greater than x squared minus 4 and y less than 2x plus 1, enter the corresponding functions and shade them. It's time for some practice with special modes. In polar mode, graph the equation r equals 2 times sine of 3 theta, with theta ranging from 0 to pi. How many petals does the graph have? Then switch back to function mode and graph y equals x cubed, drawing the tangent line at x equals 1. What is the slope of the tangent line? In summary, today we covered a variety of important topics. We learned how to use the matrix menu for operations, including reduced row echelon form, determinants, and inverses. we explored sequences and series, including how to compute them using the seq and sum functions. Finally, we examined special graphing modes, including parametric and polar graphing, as well as drawing tools for tangent lines and shading inequalities. You now have all the TI-84 skills needed for your Honors Precalculus course.